We are looking at a rhombus on the screen. In fact, there are two rhombuses. Rhombuses is the plural, or at times they are also called rhombi. Rhombuses or rhombi. Of course, we are not going to discuss singular plural in this video. What we are going to see is to analyze the diagonals of a rhombus to check whether they are equal in length, whether they bisect each other, or are they perpendicular to one another. Just like we did in our earlier video for a square. We saw that in a square, the diagonals were equal. They cut each other into two equal halves and they were also perpendicular to one another. So the same drill is going to be repeated in this video. So let's take a little knowledge about what a rhombus is first. It is a quadrilateral, a four-sided figure where all sides are equal. All four sides are equal to one another, but it's different from a square, as in a square you would have all angles also equal to 90 degree each. Each one of these angles is 90 degrees apart from the sides being equal to one another, but in a rhombus only the sides are equal. These angles are not 90 degrees. In fact, this figure looks inappropriate now. So this would be the best representation of a rhombus. All sides are equal and the angles are not equal to 90 degrees, as unlike a square. But the properties of a parallelogram holds in a rhombus, because a rhombus is ultimately a parallelogram. The pairs of opposite sides are parallel to one another. These two sides are parallel, and at the same time the sides which I am highlighting in green are also parallel to one another. So all the properties of a parallelogram, the angle sum property, the sum of the four angles is equal to 360 degrees, and the angles on the same side of the transversal, if the white lines are considered as parallel lines, then these two angles are supplementary. They add up to 180 degrees. At the same time, these two angles, if the white line is considered as the transversal and the green lines are the parallels, then the angles marked in black are also supplementary. They add up to 180 degrees. So in total, all adjacent angles, every pair of adjacent angles add up to 180 degrees in a parallelogram and in this rhombus also. So let's analyze the diagonals keeping all this in mind. Now let me get rid of this figure, because as I said, it doesn't look, it looks as if it's 90 degree each, right? So each angle looks to be 90 degrees. So let's have only this figure now. And let me draw two diagonals. Are they equal? So in order to analyze whether they are equal, we'll have to consider these two triangles. The triangle which now I am highlighting in green, because it has one diagonal as its one side, and the other triangle which I am highlighting in brown, it has the other diagonal as one of its sides. So let's compare these two triangles for congruency, as we did earlier in the case of a square. So the one which strikes me the most is this side. It's common to both the triangles, and in a rhombus, every side is equal. The length of each side is equal. So the opposite sides, these two sides also are equal to one another. So now we have two sides equal in these two triangles. So we'll have to look for a third equality. We cannot look at the sides because the third side is the diagonal. So are any angles equal? Can we conclude that any of the angles, the corresponding angles? No, we cannot, because as I said, these two adjacent angles, these two, the angle of the green triangle and the angle of the white triangle, as unlike a square they were 90 degree each, here they add up to 180 degrees, but they are not equal. So we cannot prove that these two triangles are congruent. So the diagonals cannot be proved to be equal, right? So I'll have to write a big no here. Are the diagonals of the rhombus equal to one another? No, they aren't. So now the second question, do they bisect each other? So let me draw the diagonals again. So in the case of finding out whether they bisect each other, we'll have to consider these two opposite triangles, right? This triangle which is in green and the opposite triangle which is in brown, because they consist of the diagonals, the parts of the diagonals. So let us consider these two triangles and compare them for congruency. Yes, the first thing which strikes us, all sides of a rhombus are equal in length, so these two sides are equal. Now we can't do anything about the sides, so let's look at the angles. The rhombus has opposite sides parallel to one another, right? So these two lines are parallel to one another. So what about the alternate interior angles? The angles which I am marking in brown now are equal, because if this is considered to be the transversal, these two angles are equal. And now if the other diagonal, this diagonal is considered to be the transversal, then these two alternate interior angles also are equal. So now by ASA, by angle side angle congruency, we can prove that these two triangles, which is in green and the other one in brown, are congruent to one another. Now what have we achieved by proving that congruency of those two triangles? We can say that this diagonal, this part of the diagonal is equal to this part of the diagonal, the other part of the diagonal, because they are sides of the congruent triangles. They are corresponding sides of congruent triangles, and at the same time, what I am marking in brown, these two parts also are equal in length. So we can conclude that the diagonals bisect one another, or each diagonal cuts the other diagonal into two equal halves. So I am writing a yes for whether they bisect each other in a rhombus, whether the diagonals bisect each other in a rhombus. Yes, they do. And now the third question, are they perpendicular? Are the diagonals perpendicular to one another? Now once again, I'll have to draw the diagonals. Yeah, my diagram looks a little okay. Fine. So I'm drawing these diagonals again, and in order to explore whether these diagonals are perpendicular, we'll have to look at these adjacent angles, right? Any pair of adjacent angles. So we'll have to consider these two triangles and compare them for congruency. So one in green and the other one in brown. If they are congruent, then our job will be done. So we have one side common to both the triangles. This side is common to both the triangles. And then as all sides are equal in length in a rhombus, these two sides also are equal. And just now we proved that the diagonals bisect each other. So these two sides of these two triangles also are equal to one another. So by SSS congruency criteria, side, 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 all the three sides, three corresponding sides are equal to one another. So by SSS congruency criteria, the two triangles are congruent, and hence the corresponding angles, these two angles are equal to one another. So let me mark it in brown. These two angles are equal to one another, and being a linear pair, the angles are in the diagonal, right? So this is a single diagonal, a straight line. So these two angles form a linear pair. So they would have to add up to 180 degrees. The two angles, I'm just drawing this brown color to represent these two angles here. They add up to 180 degrees, or two of these angles would be equal to 180 degrees, or each angle would measure 180 by 2 or 90 degrees. So now my conclusion is the diagonals are perpendicular to one another. So this is also 90, this is also 90. So are the diagonals perpendicular to one another? Yes, they are perpendicular to one another. So in our upcoming videos, let's explore the other quadrilaterals also in a similar fashion.